is Uncovering Chemistry by Joy Verghese. Now today we are going to discuss in this video 18 chemical property number 3, that is reaction with metal. Now this comes in topic 10.7.1c, right? So now in this reaction with metal, when we say, so this with reaction with metal, it is in haloalkanes. You will see two reactions. One is Grignard reagent, how it is formed. Another Wrutz reaction, what we are going to study. Clear? Then again reaction with metal. Now this is given behind, means after 2 pages, that is page 316 in your textbook. That is reaction with metals in haloarenes, right? Haloarenes. So in that we will be studying about Wrutz Fittig reaction and also about Fittig reaction, right? So this today we are going to study this topic, that is reaction with metal. Now in this case, in haloalkanes, what we say here, Grignard reagent. This was discovered by Victor Grignard. Actually his name, I think you must have heard about Victor Grignard. Grignard reagent, that is the reaction with Grignard reagent, right? So what we are going to study, RMgX. This is the general formula of Grignard reagent, which can be asked for 1 mark MCQ, right? Also called organometallic compound. What is this another name? Organometallic compound, because you can see in the reaction, this is alkyl group, metal, and what we say, this organometallic compound. This is how it is formed. Now how to make a Grignard reagent? When we say how to make it, so alkyl halide we will take, that is Ca3CH2Br plus Mg in presence of dry ether. Now why it is dry ether, that I will explain you the reason later on. So when this alkyl halide is treated with magnesium in presence of dry ether, you will get what? Ca3CH2MgBr, that is nothing but RMgX. This is also called carbon metal bond. What you can see here, carbon here, that is a Ca3, and that is bonded with the metal. So carbon metal bond also we can call. Now the why we used here dry ether, that is the main part. But before going to this, again we will discuss this. Alkyl halide when treated with a metal, that is magnesium, in presence of dry ether, we will get what? RMgX. That is, this is the formula for Grignard reagent, right? So this is reaction with metal, right? Alkyl halide with a metal. Now reason to avoid the traces of moisture. Now why this dry ether is used? Because if there is a moisture in this reaction, what will happen in this reaction? You can see here very clearly in your textbook what we say. Clear? Textbook page number 311, right? 311. Now in that they have given here, it is therefore necessary to avoid even a trace of moisture from the Grignard reagent. This is why reaction is carried out in dry ether, because if moisture is there, what will happen? On the other hand, this could be considered as one of the method for converting halide to hydrocarbon. Now what is the reason for that? See, here you can see this is Grignard reagent. If moisture, water here, it represents what? Moisture. Now if moisture is there in this reaction, we know water contains what? H plus and what? OH minus ion, right? So whatever proton is there, you can see here Grignard reagent are highly reactive and react with any source of proton. The word is proton means what? What is proton means? The H plus, what we call, to give hydrocarbon. Means as soon as from the moisture or from various compound, that is water is there, alcohol is there, amines are there. I think everyone know alcohol, like this when we write. So oxygen is more electronegative, so we also will get proton from an alcohol, right? So from alcohol we get if H plus, from water if we get H plus, amines also, amine I think everyone know, NH2, we get H plus, are sufficiently acidic to convert them to the corresponding hydrocarbon. Means the proton, once it get from this moisture or alcohol or amines, what will happen? This H plus will react with this Grignard reagent and it will form what? Hydrocarbon. RH means, now suppose if I write like this, CH3 and H, R alkyl and H, so actually it is what? You will get what? A hydrocarbon, CH4, right? So moisture must not be there. That's why dry ether is used in this reaction. Understood now? So one question can be asked, what is the reason there should be no trace of moisture? No trace of moisture by using Grignard reagent. So this is the answer to this question, right? Now the second reaction, that is Wrutz, when we say Wrutz reaction, that is reaction with metal here. So I think this part now clear. Reason to avoid trace of moisture, because in moisture what is there? H plus is there, that will react with what? R Mgx, right? That is plus H2O when we say. So what it will form? RH, like this it will form, and MgOH X will be formed. So this is the main thing, means it will get converted into what? Hydrocarbon, right? So that's why moisture must be avoided. Now Wrutz reaction, when we talk about Wrutz reaction, 2Rx plus 2Na in presence of dry ether, you will get what? Rr plus NaX. Now this reaction we can write it in another 2Rx. I will write like this, less separately I will write XNR. So this is 2Rx, right? So in this case what will happen? You can see here what is being removed in presence of this same dry ether. What is left out? RR is left out. So I can write here RR. What is left? Plus 2NaX is being removed. You can see it in the box. So instead, if I use here Ca3Cl plus 2Na plus Cl, I'll write, and here I'll write Ca3. What is being removed? What is removed? The 2NaCl is removed, and you can see Ca3 and Ca3 is formed. This is called Wrutz reaction. Wrutz reaction, alkyl halide is used, right? What is used? Alkyl halide. Remember this thing, Wrutz reaction. And Wrutz reaction comes in reaction of metal in haloalkanes it comes, right? So this is Wrutz reaction. Now the second part, what we say, reaction with metal in haloarenes. So in haloarenes you can see here, this is Wrutz Fittig reaction. Which reaction? Wrutz Fittig. So we have studied in Wrutz, Rx is used. So here one molecule of Rx will be there, one molecule of aryl halide. This is ARX and this is Rx. So now here you can see what is being removed. Sorry, this is different. I'll write it differently. Clear? Here halogen plus 2Na and X I will write here with Rx. Rx I will write little bit differently. So what is being removed? 2NX in presence of same Wrutz Fittig also same. What is written? Dry ether. What you will get? A benzene ring is there. You can see here, and R will be there, right? So you can see here what is there? Benzene ring and R, and plus 2NaX. Right? So if you want, you can use, instead of X, you can use Cl here, and this type of same reaction it will be. So I think this part is clear, Wrutz Fittig. Now the next one, what we are going to discuss is about Fittig reaction. Which reaction? Fittig. This is also in haloarene. So in this case you can see two benzene rings are used. I will write this, two alkyl halide, aryl halide, sorry. So halogen plus 2Na. Another X I will write here, and another aryl halide I will write like this, right? So what is being removed? What is being removed? 2NaX in presence of same thing, dry ether. So what is left out? Two benzene ring I can draw like this. So it looks like a nice frame of a specs, plus 2NaX, right? So this is nothing but diphenyl. Why diphenyl? Because you can also write C6H5, C6H5, right? So this is Fittig. In Fittig, two aryl halide molecules are used. Yeah, in Wrutz Fittig, one aryl halide and one alkyl halide. So this whole thing we will do revision here. You can see here reaction with metal, Wrutz reaction in haloalkanes, right? So in haloalkanes you can see Rx plus 2Na X, Rx only, this is what is removed, 2NX is removed in presence of dry ether, RR is the reaction. So Wrutz Fittig, always remember what is used? Alkyl halide. What is used? Alkyl halide, right? Two molecules of alkyl halide. What is the word? Two molecules of alkyl halide. Now I will just write down this second part. We will take Fittig only, so it will be easy for you to remember. See, Wrutz, two molecule of alkyl halides are used. You can see here alkyl halides are used, two molecule 1 and 2. Now in this Fittig reaction you can see two molecules of aryl halides are used. Aryl halide means benzene ring on that halogen is there, right? So in this also 2NX is being removed. You can see here, and this is your diphenyl group. Which group? Diphenyl group. Everyone understood this, right? So Wrutz reaction, two alkyl halide group. Fittig reaction, two aryl halide molecules we will use. Two aryl halide molecules Understood? So two aryl halide molecules you can see. Now Wrutz Fittig finish. Now we will compare two Wrutz Fittig. So Wrutz means alkyl halide. Fittig means aryl halide. So ARX plus 2Na. RX, what we say, remove this, what you will get, 2NH is removed and AR. So this is the same thing what we are discussing, right? So these three things you can revise it very clearly. Wrutz, alkyl halide, right? Two alkyl halide groups, Fittig reaction, two aryl halides groups, same thing. Sodium and dry ether, everywhere it is same, right? And in Wrutz Fittig reaction, aryl halide and alkyl halide. One molecule of alkyl halide, one molecule of alkyl halide and one molecule of aryl halide, right? So this is very easy to remember, reaction with metal in haloalkanes and haloarenes. So now in the next topic we will be discussing about reaction of haloarenes, and they are difficult. They difficultly give what you call nucleophilic substitution reaction. The reasons we will see in the next video. Okay, thank you.